Okay, this is the fourth installment of our review of logarithms. So if you haven't watched the previous three videos, I'd recommend that first. But in this setup, what we're going to do is apply our logarithmic properties now using kind of a nice example. So here I have a non-calculator version for us here. So I have an approximation that was gained earlier from a calculator, but I'm not going to use a calculator for the rest of these. This shows that the log of 12 is approximately 1.08, and that the logarithm of 8 is approximately 0.9. Well, if you remember what that means that 10 raised to the 1.08 power would be approximately 12, or 10 raised to the 0.9 power would be 8. So what we're going to do is kind of relate these two approximations and the properties of logarithms to find and evaluate these expressions. So the first one is 96. I want to try to take 96 and relate it back to the 12 and the 8 that I already have. It doesn't take long for me to realize that 12 times 8 is 96. So I'm going to write the equivalent expression beneath this as logarithm of that product, 12 times 8. Using our previous rule, our product rule, we now know that this product of 12 times 8 in the logarithm can be written now as the log of the first factor added to the log of the second factor. Well, I'm not reaching for my calculator yet, but I have these two approximations. I know the log of 12 is approximately 1.08. I know the logarithm of 8 is approximately 0.9. So this simply becomes a sum of two numbers, 1.08 and 0.9, for a sum of 1.98. And there's the use of our product rule. In the second one, I have 144, the logarithm of 144. And I have to try to relate that back to 12 or 8. It doesn't necessarily have to relate both of them, just one of them if I can. Well, I know that 12 times 12 is 144. So I could write this as a product and use the same product rule idea I did in the first. But I want to explore another property, the power property. So I'm going to consider this instead to be 12 squared. So I will rewrite this as the logarithm of 12 squared. Using the product or the power property now, this power of 2 would come to the front as a multiplier. 2 times the logarithm of 12. I know what log of 12 is. It's approximately 1.08. So this turns into 2 times 1.08. Using some mathematics here, if we double this, this becomes 2.16. And that's how the product rule or the power rule could be used. In this case, power rule came in handy. The third one we have on here is logarithm of 1.5. 12 and 8 to 1.5. Well, maybe multiplication occurred here. Maybe this is division. It wouldn't take long, I think, for us to realize that 12 eighths could be rewritten by divide by 4 in both of these places, as 3 dividing by 4, right, would be 3 over 2, or 3 halves. 3 halves is 1.5. So division is necessary of 12 and 8. I could rewrite this problem as the logarithm of 12 over 8, 12 divided by 8, use my quotient rule. Log of 12 minus log of 8. The approximations, 1.08 minus 0.9, and this comes out being 0.18. In the last approximation, logarithm of 24 over 36, you might look at that and say, those are 12 and 8. I don't know how many are 24 and 36, but we're going to try to do the same thing we did in the previous problems and get that to be 12 and 8. 8 times 3 is 24, and 12 times 3 is 36. So if we reduce this fraction to be the logarithm of 8 over 12, then we can use our quotient rule, log of 8 minus log of 12, to show that this will be 0.9 minus 1.08, resulting in a negative 0.18. And there's a use of the properties of logarithms for a fairly simple approximation.